So now with file streams, what we're going to look at is we've got these files. How do we actually read the data off the disk? How do we do something with the file that's there? Now, if you use your file info, we can pass in file path we'll just read in this simple file. Okay? So now we're capturing the file info for that file. These open methods give us the capacity to open this file to do something with it. So we can open it in different modes. We can do an open, which gives you the ability to choose a lot of parameters around how it opens, whether it's open shared, open isolated, open read-only access, open with read and write access, open with write-only access, and then you can set your shared permissions around, are you opening it just to write to it, but others can read from it? Are you opening it just to read it, but others can write to it? Are you locking it so no one can touch it? Or are you going to connect to it and then you don't care what happens? So you have those decisions that can be made around that. Open read kind of makes it simple. It makes a lot of the decisions for you. Open write, same idea. Open text makes even more decisions for you. Assuming that you're not reading a binary file, but you're reading a text file, it will open the file, grab the content of that file, connect a stream reader to it that's UTF-8 encoded. So it assumes a lot of factors around what you're trying to do with that file, that you're wanting to grab this file and you're wanting to read text from it. It gives you just the exact class you need to read text. So I'm going to go ahead and go the most simplistic, open, which gives you the most options. So I can say file mode dot, and I can say append. So if this file exists, I'm going to be appending to it. If it doesn't exist, I want you to create it. Create new says the file should not exist on the file system, and if it does, throw an exception. Open, open. Open or create says if it exists, open it. If it's new, if it doesn't exist, create one. And then truncate. Open this file and delete everything inside of it, because I'm going to write to it fresh. I'm going to do open. File access, we can do read write or read write. File share. We can say that we're going to open this file, but others are allowed to delete it, read from it, read and write from it, or write from it. So we decide how we want to share this file if we want to. In this case, we'll say none. So those are our three parameters. What this returns to us is what's called a file stream. File stream is that piece or that hooks onto the file and allows us to start to pull the contents of the file. Now, a simple file is not huge. It's fairly small. This file in particular is 4 kilobytes. So it's not going to break the bank to read the whole file into memory. It's going to take up 4K of memory. You have gigs, it's not a big deal. What if this file was gigs in size and you wanted to read it? It's a log that's been collecting for years, or it's a giant JPEG image. You're not going to want to load the entire image or file into memory. Instead, you want to stream bits of it, because maybe the entire file isn't relevant to you. Maybe you're looking for a specific spot in the file, and you want to start reading from that point. So the file stream gives you those tools to do things like that. So you can do what's called a begin read. If you want to perform an asynchronous read, you can, if it's permitted, you can seek to a particular spot in a file. So think of these streams a lot like an array. It has a beginning point and an end point, and it has a length. The first position is 0. The last position is whatever the length of the stream is. And depending on the type of stream it is and its attributes, you can seek to a particular spot in the stream, and you can start reading from there. You can seek to a particular spot in the stream and start writing to there. Or you can seek to a spot and then delete. So in our case, we're going to read. So we can read a chunk of bytes at a time. We can read 1 byte at a time. And when you read an array of bytes or a chunk of bytes, it's referred to as a buffer. So you define a buffer, an array of bytes, and you say, I want to read 64 bytes at a time. I want to read 8 bytes at a time. If you take a text file and you read it 8 bytes at a time, you'll get back, generally speaking, 8 characters, assuming that it's ASCII. If it's UTF-8, I think it's 16 bytes. Well, those are bits. Whatever. So, how much data do you want to read at a given moment? Often what I do when I'm reading small files is I'll say byte array buffer equals a new byte array, and I'll make the size of my byte array equal to the file stream length. So this is a buffer big enough to hold the file. And I'll say fs read, and I'll pass in my array. And I'll say read from 0, which is the beginning, to buffer.length. And the buffer length is the length of the stream. So basically I'm saying read from the beginning of the stream to the end. And load it all into that buffer. Then from there I can say, let's see what I want to do. Now I need to convert this array of bytes into text. To do that, we can use system.text.encoding, or encoder, and we can, no, it's encoding, and we can say ASCII. So let's assume that this is ASCII text, right? You guys know about the different kinds of text formats, ASCII, UTF-8, Unicode, UTF-16, or 32. So depending on the number of bytes. When you get into these Unicode sets, basically the idea is ASCII is the basic 255 characters. Your alphabet, your numbers, all the keys on your keyboard. Beyond that, when you get into the space of Unicode, then you start talking about additional characters like Japanese symbols or Arabic symbols, and it's a much broader set of characters. So depending on the type of text you're capturing or reading depends on the encoding you need to use. So let's see, bytes. So what we're going to do is we want to take the array of bytes and convert it to string. So we're going to call getString, which takes an array of bytes, and we pass in our buffer. Then we can console write file text. Okay. So one last thing to note is when you're dealing with file systems, you're always talking about this slash this slash this, directory slash file. The slash is considered an escape character inside of C#, C++, Java, all these other C-based languages. So how do you get around this? Because what the compiler reads this as is /s. Well, we did /r and /n. /r is carriage return, /n is new line. /s doesn't actually mean anything. That's why we're getting a compiler error. So I could actually go into here and I could say /r, and I'm not going to end up with a /r in my path. I'm actually going to end up with a carriage return. /s doesn't mean anything. It doesn't map to anything. That's why the compiler complains. So we can say, well, it's really a slash, so you do double slash. And it says, okay, I'm good with that. Simple enough. Escape the slash. I will only get one slash out, but you need 2 slashes to tell it that. The other alternative is you can use the @ symbol in front of your string, and that basically says that there are no escape characters or escape sequences in here. This is a literal string. It's literal to the point if I come to the end of the string and I hit enter, it will include that line break in the output string. So generally when you're managing or dealing with paths, if you're declaring them explicitly, which you're probably almost never doing it, but let's say you are, you'll want to make sure that you do either the double slash or use the @ symbol at the beginning of your string to denote that this is a non-exiting string. All right, so now that compiles. So if we have 1, so that's very fast. So what it just did is it took that file, grabbed all of the data, stored it in the buffer, took the buffer, converted it to ASCII, and then spit the ASCII out on the screen. So if we scroll up to the top here, you'll see this is my hello world file, and then a bunch of garbage that I loaded in. So this essentially pulls from that string.